In this lesson, we're going to talk about how to find the domain of a function. We've already studied how to find the domain for a list of points or for a graph of a function, but now we're going to look at how to find the domain of the function itself. There are three types of functions we're going to look at: polynomials, rational functions, which have a variable in the denominator, and radical functions, which have a variable under the radical. Finding the domain of a function really just means finding which numbers can be used for x. But it's usually easier to think about what x cannot be than to think about what it can be. Usually what we do is figure out what x can't be, then the domain is all the numbers that are left over, and we write the answers in interval notation. So let's look at each function in turn. Here I have a polynomial. So f of x equals 3x squared minus 7x plus 10. And I want you to think about what numbers we could plug in for x. Well, we could plug anything in for x. A whole number, radical, decimal, it doesn't matter. We could plug anything in as x, and that means that there are no numbers that x cannot equal. X can be anything, and the way to write that in interval notation is from negative infinity to positive infinity. This is true for all polynomials. The domain of a polynomial is negative infinity to positive infinity. Now for rational functions, it gets maybe a little more involved. We have here 2x minus 9 over x squared minus 25. Well, you'll remember from when we studied operations on rational functions, adding and subtracting, multiplying and dividing, that we cannot allow a denominator to equal 0. So in this case, we need to factor this denominator to figure out what makes it equal 0. So this denominator cannot equal 0, therefore when I factor it, that cannot equal 0. And then we see that this would be 0 if x were 5, and this would be 0 if x were negative 5. So x cannot equal 5 or negative 5. Now if you look at that on a graph, if we want to leave out negative 5 and positive 5, we're going to include all the numbers that are less than negative 5, all the numbers that are between negative 5 and positive 5, and all the numbers that are greater than 5. Now, we have to write an interval for each one, so it will be negative infinity to negative 5, union negative 5 to 5, union 5 to infinity. And you see that just leaves out the negative 5 and the 5, and it includes all the other numbers. Now let's look at a radical function. F of x equals the square root of 2x plus 7. Now we know from dealing with radicals that we cannot allow what's under the radical to become negative, because if we do, the square root of a negative result is not real. So we need to make sure that 2x plus 7 stays 0 or more. The radicand cannot be negative, and therefore it must be either positive or it must be equal to 0. So what I'm going to do is I'm going to take what's inside the radical and figure out what it takes to make that greater than or equal to 0. Because greater than 0 is positive and equal to 0, we can see here, is allowed. So if I subtract 7 from both sides, I have 2x is greater than or equal to negative 7. Divide both sides by 2. X is greater than or equal to negative 7/2. Now to put this in interval notation, we will draw the little graph, and we have a bracket because of the or equal to. Remember that it's okay for what's under the radical to equal 0, it just can't be negative. And so the domain would be bracket negative 7/2 to infinity. Now let's determine the domain of each of the following functions. The first function is 2x plus 3. It does not have a denominator and it does not have a radical. Therefore, there's nothing that x cannot equal, and the domain will be negative infinity to positive infinity. On part B, we do have a denominator, and it is x minus 2. So that means that we can't let x minus 2 equal 0. Therefore, x cannot equal 2. And the domain then will be all the numbers except 2. So we'll need two intervals to describe that, from negative infinity to 2 and from 2 to infinity. On part C, we can't let what's in the denominator, what's under the radical become negative. So 2x plus 6 must be greater than or equal to 0. We solve for x, and we see that x must be greater than or equal to negative 3. When we graph that, we see that it's all the numbers to the right of negative 3. So bracket negative 3, comma, infinity. Let's do one more set together. Determine the domain of each function. We have a radical, a rational, and a polynomial. So let's get started. On the first function, we have a radical function. We know that what's under the radical cannot be allowed to be negative. Therefore, what's under the radical has to be greater than or equal to 0. If we solve for x, we see that x has to be greater than or equal to negative 8/3. If you would like to graph it, we would be shading all the numbers to the right of negative 8/3, and the interval notation will be from negative 8/3 to infinity, including negative 8/3. On part B, we see that we have a rational function, so we cannot let what's in the denominator equal 0. This is quadratic, so to figure out what would make this equal 0, we will have to factor. So first times first would be x squared. The signs need to be different. Last times last could be 10 times 2. That way we could get our negative 8 in the middle. And now, if x plus 2 is not equal to 0, then that means x cannot equal negative 2. If x minus 10 can't be equal to 0, that means x cannot equal 10. And to graph, we would leave out all of the we would keep all of the numbers except negative 2 and 10. Now we need three intervals to describe this. So we will have from negative infinity to negative 2, from negative 2 to 10, and from 10 to infinity. And on part C, this is a polynomial. There's no radical, there's no denominator, and therefore there's no problem. There's nothing that we have to leave out of the domain, and so the domain is negative infinity to positive infinity.